Additive manufacturing, you're here, you're online with us because you have an interest in it. And there's a good reason for the interest, because when you look at the industry and you look at the rate of change that's taking place in adoption of additive as a tool for manufacturing, as a tool for building aids to manufacturing, as a tool for repair and refurbishment, there's just so much activity taking place in Connecticut, in the United States, in the world. So, you know, the purpose of today is really to take a look and work with some of our leading manufacturers and representatives from the additive industry to talk about a variety of different technologies. There's the ASTM 42 committee has defined 7 different technology areas plus hybrid. And so we didn't have time in one day to do everything. So we've kind of selected some of the most prevalent technologies for today, with the idea that when we do future summits, we're going to expand that and include more. So very quickly, our agenda for today, and I am not moving. There we go. So I'm going to do the welcoming, which we're just doing. Morning session is on polymers, on plastic materials. Very exciting. At 11:15, we're going to stop for lunch, which is provided by Optimec. At that time, we're going to break up and we're going to do self-guided tours basically through the lab. So our representatives that are speaking today will physically be here. We have equipment running, particularly on both sides of the house. So you're welcome to, you know, tour, talk to people, talk to CCAT staff, talk to our speakers that are here today, our representatives from the different companies. And then when lunch gets here, we'll let everybody know. We can grab a sandwich, just continue talking. This afternoon, there's some of you will be here for the whole day. Some of you are just here for the morning. Some are just coming for the afternoon. So there'll be a swap out of some folks. And then we're going to repeat the same thing this afternoon with metals. We have here again a selection of some of the technologies available and the leading companies, or some of the leading companies in those technologies. So we'll talk a little bit more about that as we introduce people. As a reminder, there's no photography here on site. Restrooms are around the corner, so help yourself. In the event of a fire alarm, we'll calmly exit the building out through the front door. We'll go out to the flagpole and assemble out there so we can do a head count. Last but not least is, when this is over with, we will email everyone a survey. And so this is the first time that we're offering an event like this. So your feedback on how it went, what we can do different, what we can do better, what, you know, topics you'd like to see in the future are certainly appreciated, and we thank you in advance for taking the time to do that. Very quickly, our CEO is going to actually kick off this afternoon. We'll talk more about our mission and vision. But what we're sitting in today is our Advanced Technology Center. And so we're sitting right now physically in what we refer to as our ATOM lab. So this is our Advanced Design, Automation, and Metrology lab. So we have everything from our Renishaw CMM, structured light scanning, CT scanning, thermovision, to a wide variety of contact and non-contact, non-destructive evaluation. We also have the polymer side of our additive lab over here. On the other side of the house is our ATOM lab. So that's our additive technology, optimization, and machining area. So that's where all the metal equipment is. So we, you know, encourage you during the tour to float back and forth between the two areas. We also have a composite center that's in conjunction with Pratt and Goodwin University. It's over on the Connecticut River, and so if you have any questions about that, we'd be happy to fill you in on that. We kind of talked about this. We have a number of different partners and relationships that help support each of the labs. So once again, we're appreciative of the people that are here. One of the other things, if you are a Connecticut small to mid-sized company, there's several people here that I recognize that have participated in our grant programs, but the state of Connecticut has now 2 existing grant programs that they administer through CCAT. So if you're small to mid-sized, there's 2 different grant programs that can help defray the cost of equipment, among many other things. So here again, if it's something that you're interested in, please let us know and we can give you more information. There's a lot of information on our website as well. Our first presentation is going to be on filament/composites. It's extruded material extrusion for the ASTM definition. And I'm going to introduce Paul Keefe, who will introduce our speaker. So Paul.
Thank you, Jeff. Hey, I'm Paul Keefe with Markforged Systems. Great to be here. My first time here at CCAT. Really excited about kicking this off and getting this going. But Markforged Systems, I'm based in sales. I'm based out of Boston, and these guys came up from New Jersey. And I work from Maine on down through Connecticut for Markforged. We have relationships and work with Markforged. We also work with Hewlett-Packard and their MJF systems, and a host of other 3D scanning technologies as well. We'll be here throughout the day. Looking forward to kicking this off and getting this going with Andrew, who we're going to bring up here and take us through this technology. Again, we're just really excited. Markforged is a very big company, coast to coast in Canada and the U.S., and about 22 offices here nationwide, about 400 to 500 employees, and we're really excited to broaden our relationship with this organization and just talk about this technology to you folks today. So I'm going to bring up the guy who keeps me going and keeps things moving at our company, Andrew. He's the master of all this. When companies call us and they're trying to solve things and they want to get they have some pain in their organization, try to figure things out, my first step is to find out what this guy's calendar is all about and get him on a call with the organization, understand what their files look like, what they're trying to solve, and bring Andrew in as quickly and as often as I possibly can. And very fortunate to have him here today to talk through all this technology. He's got a great presentation. So without further ado, I also want to mention, we're over here. I got Joe, our inside sales guy. We're here all day as well. But let's bring up Andrew here and get this kicked off. So thank you.
Hello, everybody. Thank you. Appreciate your time today. I made maybe a little bit too much content, so if it feels like I'm rushing a little bit, I might be rushing a little bit because the end is the best part and the beginning is the most boring. So we'll get started here. You guys ready to get started? Let's do this. All right. So I think Paul mentioned our team that's here. Paul's sales manager. We got Joe here. I'm an application engineer, and we also have, we were hoping to have Matt Simone, but he got sick from Markforged as well. And just a quick bit about me. So what do? I'm an application engineer. I work for Markforged Systems. We were formerly Design Point. We merged in December. I do a lot in pre-sales, so helping folks evaluate the technology, figure out whether it's the right fit. We do benchmarking at our lab called DP Metal, which is also on there. So I've been running our metal and composite lab for the last 4 years. So I'm very familiar with the equipment. So if you have any questions, a little more pointed. Help with implementation, training, and installing of equipment. And I have a special training session I do called the Jump Start, which is like my baby. It's like an extra day of training where I teach fiber strategy, part orientation, take companies who may not have background in this type of stuff and get them going on day one. Cool, so we, like Paul mentioned, we represent 2 major brands of additive manufacturers, Markforged and HP. And you might say, well, Andrew, how do you know what to sell people, right? They're both so great, do they compete? And the answer is, buying a 3D printer is like buying a car, right? What's better, an SUV, decked out Jeep for off-roading, or like a Ferrari, right? It really depends on where you're going, right? So that's how this works too. HP does multi-jet fusion. It's really for making high volume of parts. You want to make tens of thousands of parts, hundreds of thousands, dare I say millions, you could do that with HP. The speed is incredible. Markforged is really where my area of expertise lies, and their expertise is in making high strength end use parts. So you want to make tools, you want to make fixtures, stuff like that. There's really nothing better because of their composite technology, and that's what I'm going to tell you guys about today. So the way I decided to do the presentation was kind of through the guise of our X7 that we have over here. It's our flagship machine, and a lot of the new innovations that have come out from Markforged are available through this machine. So I'm going to talk about a couple different versions, some of the latest advances in the hardware and the software, some really cool stuff. But we'll start off with the process. How does this work? Probably going to be one of my rush slides that I kind of rushed through. Some of the materials available and the applications. I just threw up some common ones just to give you kind of an idea of like how this works. We're going to talk about the X7 Field Edition. So that's a different version of the printer we have here, which is really cool. So I think you'll find that to be interesting. We're going to talk about another version still called a Blacksmith X7, and then what's next for, you know, both the software and for the hardware and stuff like that. All right, so let's get going. So that printer over there is what's called an FDM or an FFF 3D printer. I'm guessing most people in the room know how that works, but if you don't, it's super simple. It's basically the simplest type of 3D printing. You have a spool with filament on it. A motor pulls the filament into a hot nozzle, and it deposits the material one layer at a time. And then the gantry either rises or the bed drops, depending on what brand you're looking at. If you've ever seen a hobbyist printer that has a spool on it, that's an FDM 3D printer. Markforged did not invent FDM 3D printing, but they did invent CFF or CFR, all these acronyms, right? It's the same thing. Continuous filament fabrication. They invented this in 2013, and that's the second nozzle you see there. So you got one nozzle that is FFF, and the other nozzle is CFF. It works kind of the same way. A filament passes through. It's kind of like fishing line, but it's continuous, and it kind of irons the fiber into the part before it, and it's so continuous. There's a blade in the print head, and when it gets to the end of the strand, it actually zip, and it cuts it at the end. So you're not actually even fully melting the filament. So you have a base material, which is the plastic, and then you have a continuous fiber which runs through the part, acting kind of like a skeleton, right? Picture your body. The skeleton would be like the continuous fiber, and everything else is the plastic. Or picture putting rebar into concrete, right? The steel is kind of like the fibers, and the concrete's kind of like the plastic. But the plastic's always on the outside as a base material, and the fiber is on the inside. So that's the process. We'll talk about a few different materials now. Markforged does plastics. They do composites, which is really interesting. You know, everybody does plastics, right? Very few people do composites, and quite a few people do metals too. Markforged does metals. The X7 does not do metal, so we're not going to be talking about metal, but I just wanted to say that we do have 17.4, 3 types of tool steels, Inconel, pure copper. So we are in the world of metal, even though we're not presenting metal today. So the way it works is you've got plastics and you got fibers, and you get to pick one from one category and one from the other, and then you combine the two into a composite. So depending on what application you're working on, you might choose different fibers and different plastics. The one that we print the most of is called Onyx. Onyx is the plastic, I mean. It's nylon, but it's got chopped up carbon fiber blended into it. And there are other brands that do chopped fibers as well, but it's not a composite yet. That's still plastic because it's homogeneous throughout the plastic. But the added carbon fiber adds a lot of great material properties. It makes it less prone to thermal deformation, you know, expansion, contraction. It helps with chemical resistivity, resistance to UV, strength, just kind of everything. You just blend carbon fiber in this nylon, it makes it much better. But we have different versions. There's an electrostatic discharge version, so folks in the electronics industry who don't want to walk up and shock their part, make fixtures and stuff like that out of it. There's an FR Onyx, which is a flame retardant version. and an FRA, which is a flame retardant version certified for flight. So we have a few different versions of the Onyx, and then there's a version that doesn't have the carbon in it at all, which is the white nylon. So if you're looking for less strength, more like flexibility, maybe smoother surface for coating, stuff like that, that works well. So then you can pick one of those, and then into that, you add your fiber. So carbon fiber, great, high strength to weight applications. Nothing's better than carbon fiber, so stuff that needs to be lightweight. We have an HSHT glass, which is good for thermal resistance, right? Molds, stuff like that, where you're going to be exposed to heat. Kevlar, right? We all know Kevlar. Think bulletproof vest, impact resistance, abrasion resistance, that kind of thing. And then we have a fiberglass, kind of, I call it the regular fiberglass. It's more of the economical kind of everyday fiber you might want to use. And like the picture you see there, and I'll hand out, you can see that picture here is showing Kevlar around the internal perimeter of the part, and the rest of it's made out of the black material, which is the Onyx. So, oh, and I almost forgot. We're getting new materials for the X7. I was told this month. They've already launched on our desktop machines. So it's definitely coming. PLA, what they're calling precise PLA. So a higher end version of PLA that's going to print really well for prototyping. And not out yet, but we're going to get TPU at some point, which is a rubber. So applications like handles or even maybe drive belts. So think about it. You might be able to put a continuous strand of Kevlar into your belt to make belts that don't break and stuff like that. So really excited. Came out on the desktop machines. And by the way, that was just an update one day. That's the thing I love about these machines, is that the day you buy the machine, it's the worst machine it's going to be. There's going to be software updates. There's going to be firmware updates. There's going to be new materials added. There's always more stuff added. And this is a good example of that, where now folks get to benefit from PLA and TPU, and they never, never thought they would. So this is a yield strength chart, looking at strength. And this bottom area kind of represents the realm of 3D printed plastics on the market. And even our Onyx, which I'm saying is so great, is down there. It's kind of the top level, down in that area. But when you add these continuous fibers, that's when the magic happens, and the material properties just shoot through the roof. And if you look at our continuous carbon fiber, you can see it's on the same slope as 6061 aluminum. So this is great replacement material for anything aluminum, especially when it can benefit you to lightweight. If you feel this brake handle I'm going to pass around, you give it a good go, it's not going to break. It's got that carbon fiber in it, but feel the weight. This thing, that's what it's all about. That's the big what to do. That's why we do this, for all the material properties. And just a couple quick examples, right? So let's say you got an end effector for quality control testing on the end of a robotic arm, and it has to resist a lot of cyclic loading. It's just grabbing this handle and lifting it a million times or doing something like that. Then you'd want to use Onyx with continuous Kevlar, right? It's really good against cyclic loading. But let's say you want to make a lifting tool that lifts 1,000 pounds. Not really the typical 3D printing application you think of, right? But this is a real use case. It's a CE certified lifting tool made by a company called Wartzilla, which has a clever design. And that, of course, uses continuous carbon fiber because that's the strongest stuff we have with Onyx. This is an example from a company called Lean Machine. I don't know the full story, but what was going on was that their vise was actually getting in the way of the operation they were trying to do on the part that they were holding. They needed a little more clearance underneath. So they just 3D printed and designed their own custom vise. So for that, they use Onyx with continuous fiberglass. Again, that's like your everyday kind of fiber, basic tooling, soft jaws, vices, that kind of thing. Really good for that. And last but not least, a welding fixture, right? Now you care about exposure to heat. You don't want the thing to potentially light on fire or warp. So you would use our FR Onyx, which is flame retardant, with HSHT, high temperature fiberglass. So, just to kind of button it up, it allows you to customize your material for your application. And that's what's really cool about this. Now, switching gears a little bit, I bring you the X7 Field Edition. So that is this X7 over here, but they made a very rugged version of field deployable industrial 3D printer for tactical response to supply challenges in remote locations. They turned this thing into a very portable, kind of beast. Why would you do such a thing? Who's this for? They designed it for the military. This is a direct response to needs from the DoD. And why is this important? Because Eisenhower said it best, wars have been won or lost primarily because of logistics, right? Supply chain. We see that now, right? We're all very familiar with that now, or at least more so than we were before because of everything that we've been through in the last few years. And we work a lot with the government. I can't really name too much, and honestly, I don't know. I come in, I train some of these guys, and they don't even tell me what they're going to use it for. But I know some of this stuff: MRO, maintenance, repair. A handle breaks on a Humvee. Maybe it's going to take them a week to get the next one sent in, so they can print one right away. I mean, print a good version with springs in it that works really well, that you'd never be able to even tell was a 3D printed handle. So as a bridge for other parts, as they're waiting for other parts. But also the same way that you guys would use it, tools and fixtures, right? They're going to make tools that allow them to make their end use parts. And that, from my experience, has been one of the highest uses of a machine like this. So how does it work? You go out in the field with this guy. You know what? There's a little video I embedded. I shouldn't even get into it. So comes in a rugged Pelican case. Really, the thing's really robust. Has component locks on it, so it locks the gantry, it locks the stage, locks the print heads. That way nothing gets jumbled and damaged in transportation. And you could set this up in minutes. It's very much like the X7. You can ask Jeff, I came in very late last night, set up this printer. It might have taken me 5-10 minutes to get this thing set up. So it's just like that. You're fully set up very quickly. And why do you do it? Parts at the point of need, right? This eliminates the supply chain, so to speak. So I figured the next question would be, well, how do you power something like this? And as I was thinking of how to present that to you guys, a video came out from a colleague of mine, Charles Liu, which has a very unfortunate still at the beginning of it. And, oh, you know what? Jeff, you have to hit the little button here to make it play. You know how to... I think the other one works automatically, but this one, for some reason, it didn't want to work that way. Ah, there you go.
No. I'm not seeing
No mouse cursor, right?
Yeah. Oh, there we go.
Yeah.
You can see it over here. Oh, okay.
Oh, there we go.
Hello? Hello?
Howdy, folks. Markforged. Sometimes you find yourself in a remote area in urgent need of a part. Today, we're going to show you how to print strong parts anywhere in the world using just solar power. Introducing the X7 Field Edition, the ruggedized version of our flagship composite 3D printer, the X7. The X7 Field Edition comes in a rugged case meant to withstand transport through harsh environments in extreme conditions. Even if you don't have access to reliable mains electricity, with just a few simple steps, you can print high-strength industrial parts anywhere in the world. To get the printer up and running, there are a few things you need to do. First, you need to get the printer out of the box. Grab the printer layer from inside the case, put that on top. There are two tag safety mechanisms within the printer that protect it during transit. After you remove those two safety mechanisms, you'll be able to freely move the print head and Z-stage. If you're in an area where you have access to power, you can plug this in directly to 120 or 240 volt mains power. The machine really only draws about 2 amps and operates on about 150 watts max. Right now we have this one back here running off the solar panel. Next, place the print bed into the chamber, align it to the back. You'll hear a resounding click, and you'll be ready to print. After you've got the printer set up, boot up your computer and open up Iger. Upload your part, select your settings, and hit print. That's it. The ability to use continuous micro reinforcement allows the X7 Field Edition to produce parts as strong as aluminum. One really cool thing about this printer is that it's capable of accessing our blacksmith software, which is able to calibrate and automatically inspect parts as they're printing. Whether you're in the armed services, field services, or just need to print parts in places that the traditional supply chain can't get you, the X7 Field Edition could be a solution for you. One of the downsides of not needing a heated chamber is that this machine here is not going to keep me warm. So I'm going to go inside and get a cup of coffee. See you later.
Yeah, I'm like not the hugest fan of putting videos because I'm like, I should just be telling you this, but 2 videos came out which were so specific to what I was going to talk about within the last week. I was like, I just can't say it better. So there's another one, and then there's another one. So switching gears a little bit, we're now going to talk about another version of the X7, and this is really cool. So for the last 250 years, machines have had no idea that they're making parts that are out of spec, and now that's about to change. So I bring you the Blacksmith X7. So this is something that you do to the X7 that you already own. You can take that X7, which is the Gen 2, the regular one, or you can take even the Field Edition that we were just looking at. And what you do is you purchase an inspection calibration bed from Markforged, which is a very special high precision bed. You put it in your X7, you hit calibrate for blacksmith. It moves around for 2 hours with the laser and the print head doing all kinds of crazy stuff. And then at the end of 2 hours, you now have a blacksmith X7, which is better than every other X7 in the field. It's going to be more accurate and have better tolerances and more precision. And it also unlocks a very special capability. It uses the laser that's in the print head, this laser micrometer, to do a scan on the part as you're printing. So as you're printing, it's also scanning and generating a point cloud of data, which then it puts over a representation of the STL model, and you can check your parts instantaneously without doing it manually with calipers and visually. Problem with that is you give 2 different engineers calipers, they come back with 2 different numbers. Or the other way this is done is with CMM inspection, and then you need, there's a learning curve, you need an operator, it's expensive, right? So what this does is immediately off of the print bed, you can go into your software and you can check your tolerances. You can immediately look at the part, look at the point cloud. It has this bar that slides, and as you slide it over, you can pick your tolerance. You can pick, let's say, 4 thou or 5 thou, and only the dots will remain that are within that tolerance. So you no longer need to check your part. You now know if the tolerances are correct. Second thing, it has diverse feature recognition. Really cool. You can just hover over any features on your part. It knows it's a cavity. It knows it's a post. It finds all this stuff. It's really cool. And you can pick 2 different features, and it gives you the relationship between the features. So if you want to check an angle, that was supposed to be 90, but we can see that that's actually 89.83. For better or for worse, right? But now you know what it is, and you can make a decision. Is this good enough for me to move forward? Pick 2 different posts, for example, and you can check the distances between those features or different planes. You can throw your calipers out, in essence. You no longer need to check your parts. This is done automatically. Something that's coming out soon, but I was told by the Markforged folks that I was speaking at an event in Utah 2 weeks ago that it's coming out so soon I can talk about it. What's called verifying fiber verification. So right now it scans the outside of the part as it's printing, but it's going to start scanning the inside of the part as well. And it's going to check that fiber pathway. And if it sees something that it doesn't like, it's going to automatically stop the print. And that can be pretty valuable in saving time. Success rates are high in these machines, but like anything else, you know, you run into something, right? So that is pretty valuable. And kind of the best part, you get an inspection report. It tells you what printer was used. Let's start. Yeah, let's just, if we don't mind, just wait. I think we're getting to the end here, so it'll be just a few more minutes. I want to just make sure I get in. Sorry about that. So the inspection report will show you areas where it feels like the part's in tolerance and out of tolerance with graphic representations. Tells you what kind of printer was used, what kind of material. So there are some folks who need to get some of their parts certified. Now they can skip this extra process and they can just hand this report in with the part. Or maybe you're somebody who just makes parts for a living, like job shops, something like that. Well, now you can make a part for a customer and hand it off with a report that says this part's in spec and this part's good to go. So love that. You can use that inspection report as well. Quick customer profile. This is another one of those videos that came out that's so good I had to include it. We're not going to play the whole thing, but I'm just going to play the first few minutes. But these guys, they'll tell you what they do. They make they're the biggest windmill company in the world. They make these 900-foot windmills, which are these feats of engineering. And they have 14 Blacksmith X7s. And one of the applications, which they're going to talk about, they use it for go, no-go gauges. They mark these giant fan blades. And so that way, when they install them, they can align them correctly, and they can't just 3D print a gauge. They have to know that that gauge is perfect, right? Because of the precision needed, so they don't have a catastrophic failure. This one should work.
Wind is plentiful. It's just wait.
Wind is our fuel. We see it as a sustainable source for reliable energy.
As a renewables company, Vestas has a high stake when it comes to sustainability and carbon footprint reduction.
Vestas is the world's largest wind turbine manufacturer globally.
Our mission is to drive the world towards renewable energy. We have design elements that are kind of scattered around the globe. We have a centralized team in India, people in Denmark, in the United Kingdom, here in the US. But we could be having a part shipped from Germany to the United States. In terms of sustainability, it has a substantial amount of fuel and time and resources.
The solution to that is direct digital manufacturing, or as we call it, DDM. We've equipped all of our blade manufacturing facilities with Markforged printers to have a rapid response to an ever-changing product.
We use it for instantaneous validation of design concepts. We use it for collaboration. We use it to free our manufacturing processes from the constraints of outside suppliers. The DDM, we don't compromise. What we've done to kind of flip the script is we're no longer just providing the instructions, we're providing the physical art in near real time. It's the closest thing to teleportation I think you can get. Blacksmith has been mission critical for us to enable the functionality and the capability of inspection and calibration of a tool during the manufacturing process. For blades, in ultra high inclement weather environments, they're prone to lightning strikes. So we incorporated a proprietary lightning protection system called a lightning tip receptor. Conventionally, just for the geometric aspects, something like this would be CNC'd out of a cheaper material like aluminum. The validation of that geometry, fit, form, and function, that could take weeks. We can validate this the same day as the design, and we could iterate numerous times, right? We could test one concept after the other, and then we can print the same exact design out of actual copy. You can't do that with conventional manufacturing. This is one half of the tool that's called the TC marking tool, or top center marking tool. It's used to place a witness mark or an indicator mark on our blades for the assembly process when it gets out to the field and goes out. So if the blade is out of clock position by even 1.5 degrees, that can result in catastrophic failure. So we need to assure from manufacturing that we provide our colleagues in construction and assembly proper features to be able to align the blade. A tool like this, the typical validation process, it would have to be taken to each physical specimen, each physical blade type to be checked. Well, with this, it manufactures the part, performs the blacksmith in-process inspection, calibration, so we guarantee repeatability every single time. We have full control over that because we know
Okay, for the full video, it's on YouTube, but it gets a little. Okay, so what's next for blacksmith? Coming to the end here, guys. Artificial intelligence, or if you like this meme better, if that gets you more excited. Couldn't help it. I didn't want to do it, but I had to do it. So what's going to happen is there's going to be a loop. So it's going to take all this same information from your part, but now it's going to loop it back into the software. So the next time you print your part, it's going to learn, and it's going to print it with better tolerances. Not only that, all the information that these printers are learning is going to get put back into the entire, field of printers. So every printer is going to benefit from this, but it's going to learn. It's going to get smarter, and every time it prints that part, it's going to make it better and better. So really excited for that, especially on our metal system. We're working with a system where there's a lot of shrinkage. So when that gets implemented for a metal system, that'll be really neat too, improving tolerances there. What's next for Markforged? Couple things. One, they went public like 6 months ago, and now they made their first acquisition with that influx of cash they must have gotten. It's called Teton Simulation, and what these guys do, they are now owned by Markforged. They make something called Smart Slice. And what Smart Slice is basically FEA. So you get to say, affix the part on one end, put a load on it of 500 pounds, and now it's going to tell you if the way you have the part set up is going to be successful before you print it. And it's going to give you probably 4 or 5 other options in ways that you could print it that are going to say kind of pass, fail, showing you different ways that you could print the part. So really excited for that. That's something that our customers have wanted for a long time, because putting the continuous fiber in, it's good to take some of the guesswork out of that and to actually know where you can push the limits on that and how to use it without using too much, right? The other thing is the X7. It's the last year of being the flagship printer. We're coming out with what's called the FX20 this year. And I'm very excited. We're getting our demo machine in our lab, I think this week while I'm away. So really excited to get back and see it. It's bigger. It's not like that printer over there. It's a big giant printer, heated bed, heated chamber. The build volume is 5 times that of that machine and 16 times that of the Mark II in the corner over there. So it's bigger. It's hotter. Heated bed, heated chamber allows us to do some more advanced engineering thermoplastics. We're launching with Ultem 9085 filaments, and you're going to be able to put a continuous strand of carbon fiber into Ultem. So it's going to do something, you're going to be able to make a composite out of Ultem and do something that was never done before, which is really cool. And we're expecting other plastics like that down the road, although I won't name names because they haven't really told me yet, but we'll get other stuff like that, like Ultem. It's much faster. Just anecdotally, they say it's about 5 times faster. Did a little comparison yesterday, just on basic parts. Looks to be at least 30% faster with the fastest settings. But I guarantee there's some ways that it's it's geometry dependent, and there's a lot of other factors that go. And it's smarter. The thing's loaded with sensors. So you're gonna have moisture sensors in your materials, in your material box, lack of a better word. And it's gonna be more accurate because of that, and smarter, and just have a lot more capability. So I threw in, this is the end, I just threw in a 1-minute little hype video because it got me excited. So we'll just finish with this, and then we'll get to some questions. Well, that's all I have for you guys today. Thank you very much. We'll answer some questions, and I'm dying to know what question you had, sir. That's a great question. The tolerances on this machine as it stands are plus or minus 6 thou in the XYZ. To be honest, I don't have a metric for how much it improves it, but well, and the reason for that is also that second bit where it does that loop in isn't out yet, so we don't really have access to it. So I know it's better. So that's all I got. Sorry.
Two quick things. For those that are watching this online, please feel free to type your questions in and we'll be happy to ask them for you. There's a questions section or just in the chat feature. And if the speaker would please repeat the question so that the people online can hear it.
Gotcha. So that first question was about blacksmith. It was asked, how much better tolerances do you get from using that? And the answer was better than plus or minus 6 thou. That was all I had. Yeah, I think that's also, so the gentleman asked, what tolerance can blacksmith get down to? I guess that's a little different, right? Because we're saying it's going to loop and it's going to loop. So you're saying, where does that end? It has to end somewhere, right? So it's got to level off at some area. And again, unfortunately, I don't know, because that second half, which we're expecting maybe to come out this year, is not, it's only the part with the data cloud. Oh, it's down to the 1 micron, that laser. Yeah, it's very, very accurate. Yeah. Any other questions?
So, as an OEM of the printer, what changes have you seen in the last 2 years as far as the range of industries starting to onboard technology? And who are some of these industries?
Yeah, that's a good question. And we get that a little bit, like, what industries do you specialize in? It's a hard question to answer because it's really, this tool we find can be very good for almost any manufacturers, because almost every manufacturer needs some sort of custom tooling and fixturing. So we're working in aerospace, definitely more and more with the FX20 coming out. That's definitely geared towards those types of customers. We're working with a lot of DoD customers, like I had mentioned, healthcare. It's really broad, really just broad. Almost anyone who's manufacturing anything can get some good value out of a machine that can print aluminum strength parts, we find. Question was, what industries are we most prevalent in? Yeah, I would say, just manufacturing in general, anyone with CNC machines, lathes. See, this really complements your traditional manufacturing. That's what a lot of people don't get. They think it's going to replace your CNC. It's not going to replace your CNC. Matter of fact, you might want to put your more important jobs on your CNC, where you have an operator and it's to extremely high tolerance. But what this can do is take some of the heat off of your machine shop. This transfers some of the work from your machine shop to your engineering department. And I've been told, and what I'm seeing in the field is that these machinists, they're retiring faster than they're coming in. So there's a real added benefit to making your machine shop that's as traditional a little leaner, and taking some of that work and transferring to the engineering side. Well, there's got to be one more. If you're thinking it, someone else is thinking it, right? All right. And with that, I leave you guys. Thank you so much. Okay.
So the expedition there, talk more about who's stopping that or who's running that out?
Which one?
With the X7 expedition.
Oh, the field edition? Yeah, I mean, like I had mentioned, that's really DoD, that's really government. I haven't seen any companies outside of that. I didn't show it to you guys expecting a lot of people would go, oh, I'm gonna grab that tomorrow. You know, I just thought it was really, really cool. So it's just really, you know, DoD military, we've worked with, you know, all different types, you know, Army bases, NSA, NASA, a bunch of different folks. So it's pretty broad. And like I said, I don't get that extra. They don't tell me what they're doing with it. You know, they don't share that. All right. Oh. I mean, you know, it's hard to say without looking at like a specific application and how it's going to work. But I would say that that is part of what we teach is the design aspect of it in our Jumpstart session. So there is a lot to looking at the type of load, whether it's tensile, compressive, bending, and using a fiber strategy that meets, you know, that's good for resisting that type of load, because you don't want to overuse fibers, right? You want to use just as much as you need to and be strategical with it. Specifically for fatigue, I would probably recommend like Kevlar, probably something like that, a fiber like that. But it's hard to say without looking at the application fully and fully understanding it. So, sorry, might be a hair vague. Sorry. You got one in the back. So it is similar to our X7, where it's singly extruding plastic, and then it does have a fiber nozzle, so you can do an additional fiber with it. And then there's a third nozzle, which does a special support material for the Ultim. It doesn't use, like, normally this uses the same material it's printing in. There's a special Ultim support material that comes off smoother and nicer. So there is some, but yeah, it's not designed necessarily that you're going to make a green frog with blue eyes or something like that, where you'd be using multiple in essence like that. At least not yet. You know, these machines are always over-engineered, so they can add capability like that. We'll see in the future, but currently it's a plastic, it's a fiber, and maybe a support material if you're. Oh, for soluble. You know, it can be. It depends on your application. There's a benefit and there's a disadvantage, right? When you're using soluble supports, one of the great benefits is if you're doing internal channels, you can make them very smooth, or you can make very smooth parts in general. The downside is that it takes time. You know, your part's done. Now you have to put it in a vat. You have to melt those supports away. With breakaway supports, the advantage is it's much faster. Right, so for tools and fixtures where someone might not care about a little bit of a rough surface, you can rip that support off right now with pliers and you're ready to go. Something I would say is that with Hawkridge Systems, we work with a company called MT. They make vapor smoothing machines, really cool technology. You can take these parts and in essence, it puts it in a vapor cloud and melts the outside surface and it smooths it out. So you could potentially, if you want to smooth out parts, get rid of layer lines. It actually increases the strength quite a bit too. You can vapor smooth your parts to get some surfaces like that. A good question though. Thank you. All right, with that, I will leave you guys. Thank you so much. I really appreciate your time today. Special for me to get in front of people, so.